In this video, we're going to take a look at working with filters in ParaView. Filters are essentially units of processing that you can apply to any data. You can read a data set and then apply a filter to, let's say, dissect this data set, create a slice, create a clip to build a set of isosurfaces, contour lines, etc., etc. So filters are functional units that process the data to generate or extract additional features. And then you can apply filters to the output of other filters, and this way you build the visualization pipeline. ParaView has more than 100 different filters, and the most common filters can be found right here in this bar. For the full list of filters, you can go to Filters, Alphabetical, and it will give you a very long list. And all filters that cannot be used in a current situation will be grayed out. The ones that you can use now will be shown to you. So let's start with a very simple example. I'm going to open a file, File Open, and in the data directory, I'm going to navigate to these files. So there are 30 files called 2D, then 3digits.vtk. I'm going to load the first one. Say OK. It's a VTK file. And then when I hit apply, I see a visualization. Now, if I try to spin it in 3D, it actually doesn't spin because this is a two-dimensional data set. And right here, you can see that it says 2D. So now you're automatically in two-dimensional visualization. Now, let's apply a filter that will make this data set three-dimensional. We're going to apply a warp by scalar filter that will offset each point into the third dimension by the value proportional to the function at that point. So here I will make sure that you click on your data set in the pipeline browser, and then I go to Filters, Alphabetical, and then at the very bottom, there's a filter called Warp by Scalar. You can also access this filter by going to Filters, Search, and then start typing Warp by Scalar, and you will find it. So if the filter is grayed out for you, that means that you have not clicked on the data set or you have not imported the original data set. So make sure that you import the data. You can see your visualization in 2D, and then click on the data set in the pipeline browser, and then bring up the filter. So now I hit apply, and as you can see, something happened. So the data set became three-dimensional, but it's still shown in 2D in my case. So I'm going to click on right here where it says 2D. I'll make it 3D, and then I'll click on one of these predefined orientation buttons, for example, this one. And now you can see that I have a three-dimensional data set. And the value of offset at each point is proportional to the value of function at that point. So in the properties of the filter, I can add in the scale factor. I'll make the offset smaller. Let's make it a little bit bigger. Here it is. And now I have a nice three-dimensional object. This slide shows the most commonly used filters, and these you can find in the toolbar. There's a calculator filter that you can apply to any data set, and it will calculate a new variable based on a given mathematical expression. A contour filter extracts isosurfaces or isocontours, depending on whether your data set is three-dimensional or two-dimensional. A clip will dissect a data set with a plane and then remove all geometry, all data points on one side, and then keep all data points on the other side. A slice will also dissect a data set, but it will create a two-dimensional slice. A threshold will let you throw away all points inside a given range or outside a given range. A glyph will let you place an object on top of each data point, or perhaps on top of every 10th, etc. data point. And this is useful for a number of things. For example, you can place a sphere on top of each point to make it more visible, or you can place an arrow to indicate the direction of the vector field. A stream tracer is used to build streamlines for a vector field. Warp by vector is somewhat similar to warp by scalar, but it will displace each point by a vector field. Then there is group data sets and extract level. So let's load a slightly more complex data set. You can find it inside the data directory in the zip download. The file is called disc.outref.x2, and this file I took from the VTK and ParaView tutorials. When you load this file, make sure you click temperature, velocity, and pressure variables. So here I go to ParaView. I will click on disconnect from server to start from scratch. And then I will type file open, go to the data directory, and I'm loading the file disk out rev.x2. Say OK. Then here make sure you click on pressure, temperature, and velocity, and then click apply. Let's color our data set by the temperature variable. So you can see the temperature goes roughly from 290 degrees to 910 degrees. And you can verify by going to the information panel, and you can see the range of temperature right here. So let's go back to properties. And now let's apply a calculator filter. So I'm going to click on the data set, and then I bring up the calculator filter from the toolbar. And then here where it says result, I'm going to say log temperature. So I'm computing a new variable which is called log temperature. And then here I enter mathematical expression. So I can either use my keyboard to type in the formula, or I can use this built-in keyboard. So I'm going to say log 10 off, and then scalars will give you a list of scalar variables in your data set. So I'll bring up temperature and then close the brackets. I'll hit apply. And now, as you can see, my data set is colored by the log temperature. Nothing changed visually in the plot itself, but if you pay attention to the color map, you see that now it says log temperature, and it goes from 2.5 to 3, which is roughly the right range for logarithm base 10 of our temperature. Let me delete the calculator filter, and let me bring up a contour filter. So starting from the original data set, I click on the contour filter. And here in the properties of the contour filter, I'm going to contour by temperature. So I'm going to build an isosurface of constant temperature. And temperature ranges from roughly 300 to 900 degrees. So let's pick a value in the middle, let's say 400 degrees. And then I hit apply. And here's my isosurface at 400 degrees. Let's build another isosurface. I'm going to, in the properties of the contour filter, I'm going to click plus and then add another value, let's say 650 degrees. I'll hit enter, then I'll hit apply. And now I have two isosurfaces. And you can see that these are two different temperatures because the colors beige and blue correspond to 650 and 400 degrees. Let's erase these two temperatures. And let's click on this button that says add a range of values. So these will give a number of samples. Let's just select 5 from the absolute minimum to the absolute maximum of temperature on a linear scale. And optionally, if you want, you can use some other scale like logarithmic or geometric scale. I'm going to use linear scale. And then I'm going to say generate. So this generated 5 different isosurfaces. Now I hit on apply. And as you can see, now my temperature is shown in these 5 isosurfaces. I can make them semi-transparent. If we go down, you will see you will find an opacity slider, and I can make them semi-transparent like that. Or maybe I want to show them as wireframes. So I'll switch to the wireframe view, and then I increase their opacity. So now they're clearly visible. If I'm going to show the original data set, I will click on the eyeball icon next to the original data set, next to the reader. And here's my original data set. So if I want to see the isosurfaces now, let's make it semi-transparent. So I'll search for the opacity right here. And then now you see the original data set as well as the isosurfaces of temperature. Let me click on the original data set and I will apply a cliff filter. So now I apply 2 different filters to the original data set. There is the contour filter, and then there is the cliff filter, which is applied to the original data set. So in the cliff filter, I have several options. I can either modify the properties of the cliff filter by hand, origin, the point through which I'm drawing my plane, and the normal vector to this plane. Or I can simply grab the normal vector and spin it in 3D, and then I can grab the plane and move it around a little bit. So for example, like that. And once I'm happy with the orientation, the position of the plane, I hit on apply. And let me invert the selection. I'm going to uncheck this box, hit apply. And now I see the original dataset, which is semi-transparent. Let me hide it. And let me also hide the controls. And now I see my clip dataset, which is not transparent, and also the isosurfaces of temperature as wireframes. And let me switch back to surface view for the isosurfaces, and let me make them semi-transparent like that. And here we go.